IQ is normally distributed with a mean of 100 and a standard deviation of 15, mu 100 sigma 15 for the population. Researcher believes that they developed a medicine, positive effect on population mean IQ. Specifically, she believes that she gave the medicine to everyone in the population mean IQ increased, and the population standard deviation would not change. She wants to use a directional hypothesis test to test her theory. She takes a random sample of 25 people from the population and gives them medicine. Then she calculates the mean IQ of 25 people in her sample. The sample mean is 100. Write out null and alternative hypothesis for this researcher's directional hypothesis test using the correct notation. Then state the null and alternative hypothesis in your own words. Okay. So the notation for null hypothesis is H0. Okay. Okay. Null means there's no, it's directional and no positive effect. So mu for the control group, after intervention, mu med is either 100 or smaller, because no positive means it's got to be one of these. E doesn't change, or it got smaller. And alternative hypothesis, notation for alternative hypothesis is H1 instead of H0, and that's gonna be mu med is actually increased, positive effect, greater than 100. Okay. State the null and alternative hypothesis in your own words. Didn't I just say? Okay, so null hypothesis, there's no positive change. There's no change. There is no positive change, positive effect on the medicine has no positive effect on the mean of population. That's null hypothesis. No positive effect on population mean. And alternative would be there'll be positive, positive effect. There is positive effects on population mean. Okay. Let's look at the second problem. The alpha level is 0.05, and researcher is doing a directional hypothesis test where she's expecting a positive effect. Where is the critical value of z? 0.0. If you look at the table, actually I already remembered it, so it's it's here. Z equal 1.65. It's actually somewhere between 1.64 to 1.65. That value, p value for that is 0.05. You can't go to lower end because that could include p value of 0.051 or something. So take this in, and that's a z value, critical value of z. Mark the critical value on the standard normal distribution below and shade in the critical region. Critical region in this case is here. Well, okay, beyond this point, when it goes into this region, another critical region, means there was some effect. And below this critical region, these differences in the value is not critical. In other words, it's just a matter of maybe sampling error, so this section is not critical. Effect is not critical. Anyway, let's go to the next one. It's just solving this problem. Calculate the z-score for the sample mean of 100. Calculate the z-score for the sample mean of 100. Okay. What it's trying to do is, yeah, this is 100, right? And 101. What it's trying to find out is, the possibility of people getting 101, if there is no effect, from the population of, IQ mean of 100, standard deviation of what was it, 25, trying to figure out, what are the possibilities of getting 101, someone getting 101, or someone in the population getting 101. Okay, so that's what I'm trying to figure out. In other words, just getting a z-score for that, and z-score is actually gonna, okay, it's just okay, so z-score for 101. Okay. Okay, how to do that is get 101, and minus mean is 100 in the sample distribution, and then divided by standard deviation. Standard deviation for that is, okay, okay, that is population standard deviation divided by square root of wait a minute, I don't remember the standard deviation. Oh, 15, that was 15, so my bad. Okay, 15 and the sample size, square root of sample size. So okay, so here 3, that means 0.33. okay, so it's 0.33. Use your standard normal table to determine the p-value for this direction hypothesis test. And the p-value for that, you actually need this. What you want to know is here, and so instead of getting looking at the positive number, I'm gonna just look at the negative number and cut the middle calculation. 0.3 1, 2, 3. Is that right? Yeah. So 0.3703. That's 0.3037. Was it? Yeah. Right. So it's a P 0.3037. That's a P value. Okay, unfortunately though, that's okay. Let's go to the next one. Okay. 1.65, and this is like 0.33, and this is 0.05, and this is 0.3037. So in other words, P value 3037 is larger than the alpha level of 0.05, and or Z equal 0.33 is smaller than the z-score for alpha level 1.65. So the effect observed on in the sample mean was not statistically significant enough to conclude that there was a positive effect. So there was no positive effect. Make decision about this to reject. So fail to reject. We didn't reject it, right? Because there's no positive effect. Was the null hypothesis, and from this, it looks like there's no positive effect, so we fail to reject. State the conclusion in your own words. I don't know. The effect was so small. The increase observed in a sample was not statistically significant enough to, so we assumed that the medicine did not have any positive effect. Okay, so the medicine didn't have positive effect, huh? Okay.